Hi everyone and welcome. Here you can see the Modbus IO card from Augmatic Technologies Private Limited. So this card is brought to you by the Augmatic Technologies Private Limited and they are the manufacturer of this Modbus serial IO cards. Okay, now this Modbus IO card is having capability of 4 analog input channel, 4 digital input channel and 4 digital output channel, and this IO card is having capability of 4 analog output channel. Okay, and I have connected this two LED with the DO1 and DO2. Okay, I have connected this sensor with the DI1. I have connected this DC voltmeter with the analog output 1, and I have connected the analog output 2 channel with the analog output 1 channel. So now in this video we will see how we can test this two Modbus IO card, or how we can troubleshoot this two Modbus IO card. Okay, so I have connected this LED sensors and DC voltmeter with this IO card, and this both Modbus IO card is supporting Modbus RS485 protocol. So you can see here I have connected these two cables, green and blue cable, from here to here, and then after from here to this ATC converter. So this ATC converter is nothing but the USB to serial converter. Okay, so I have connected serial cables here, and the second end of this ATC converter is the USB, so I have attached it to my laptop. Now we will open the Modscan software and we will try to understand the register setting of this two Modbus IO card. Okay, so here I have my Modscan open. Okay, you can see on the screen that I have opened my Modscan. Now this window is specifically for digital output and the digital input channels. Okay, and the second window, this window, is specifically for analog input channel, and the third window here, as you can see here with the device ID 8, this is specifically for analog output channels. Okay, so if we change any holding resistor value here, then it will affect my DC voltmeter here, and it will also affect the analog input 2 channel of this card. Okay, so this first window is associated with the digital output of this channel and digital input of this channel. Okay, and the second window here, you can see here, this is the second window which is associated with the analog input channel of this card, and the third window here, you can see here, which is associated with the analog output channel of this card. Okay, so I hope that thing is clear. Now if you go to connection and if you click on connect here, then you will see this ATC converter is connected with my laptop on COM3 port. Okay, so that is why I have selected COM3 port here. Now this both Modbus IO card is having common configuration like baud rate 9600, word length 8, parity none, and the stop bit 1. Okay, so I have filled the common setting here, but the difference between these two Modbus IO card is their slave ID. This Modbus IO card is having slave ID of 1, or you can say device ID of 1, and this Modbus IO card is having a slave ID of 8. You can see in this window, this is having, let me close it. This is having slave ID of 1, or you can say device ID 1, here device ID 1. So this two window is associated with this Modbus IO card, and here you can see the device ID 8. Okay, so this window is associated with this Modbus IO card. Okay, so I hope that thing is clear to you. Now let's go to connection and click on connect. And I have already told you that I have filled the common configuration of this two IO card. Okay, which is having baud rate 9600, word length 8, parity none, and the stop bit 1. And this ATC converter is connected with my laptop on COM3 port, so that is why I have connected COM3 here. Okay, now let's press on OK to connect with this both Modbus IO card. So you can see here we have previously warning here that not connected with the device. That warning is gone. Okay, now this digital output, okay, if you want to operate this digital output, then the coil number of this digital output is from 1 to 4. Okay, 01, 02, 03, 04. So this 4 coil is associated with the digital output of this channel. Okay, so digital output 1 is associated with the 01, digital output 2 is associated with the 02 here. Okay, output 3 is associated with the 03 03 coil status, and 04 is associated with the DO4 of this card. Okay, now I have put the status as 1 for this DO1 and DO2. So because of that, this 2 LED is on. If I turn it off from here, okay, if I turn it off from here, then you can see one LED will be turned off. Okay, so green LED is turned off now. If I want to turn off the red LED as well, as you can see here, which is connected with the DO2 of my card. Okay, so I can turn it off from here. Okay, so turn it off and update. Okay, so it got off. Now you can see here 05 is associated with the DI1. Okay, now my sensor is NPN sensor, so if the part is not present on the sensor, it will give me 12 volt. Okay, and if the part is present on the sensor, it will not give me anything. So as you can see, 05, the value of 05 is 0 now. Now the value of 05 is 1. So this sensor is connected with the DI1, and this is the NPN sensor. Okay, so whenever the part is not present on the sensor, it will give me output as a 12 volt. So that is why you can see here high. Okay, you can see here 1, you can see here true. But whenever the part is present, it will not give me anything. So it will give 0. Okay, that is why you can see there is a false, or you can say there is a off state. Okay, so this 05 coil status is linked with the DI1, 06 is linked with the DI2, 07 is linked with the DI3, and 08 is linked with the DI4. So you have to remember this, okay, or you have to note it somewhere to use this card with other applications like Node-RED, Ignition SCADA, Plant SCADA, or any other IoT gateways. Okay, now let's talk about this output. Okay, analog output card. So you already know that analog output card having a slave ID of 8. Okay, and this analog output card I have set it to 10 bit, so maximum value I can provide is 1023. Okay, here I can provide maximum value of 1023, and I have already provided the 999. So if I provide this 0, okay, 0 value here, then my this DC voltmeter will be turned off. Okay, so let me update it. Okay, you can see my DC voltmeter got turned off and I am having 0 here. If I update the value 0 on this 40,002, then as you already know that my AO2 is connected with the AI1, so this 40,002 is directly connected with this 40,002. Okay, because I have connected this 40,002 with this 40,002 with this white and red cable. Okay, so if I put it 0 here, or if I update the value to 0, then you will see changes here. Okay, you will see the value 0. Okay, so this is how you can troubleshoot your both Modbus IO card. Okay, so this digital output is associated with the coil status from 01 to 04. 01 is linked with the DO1, 02 linked with the DO2, 03 linked with the DO3, and 04 is linked with the DO4. Okay, 05 is linked with the DI1, 06 linked with the DI2, 07 linked with the DI3, and 08 is linked with the DI4. Okay, so you have to remember this, and this is for our analog output card. So 40,001 is linked with the analog output 1, 40,002 is linked with the analog output 2, 40,003 is linked with the analog output 3, and 40,004 is linked with my analog output 4 of this Modbus IO card. Okay, and now here 40,002 is linked with my analog input 1 channel, 40,003 is linked with the analog output 2 channel, 40,004 is linked with the analog input 3, and 40,005 is linked with the analog input 4. Okay, now if I want to turn on this DC voltmeter again, then I have to update the value of my 40,001 holding resistor. Okay, so if I set the value to 300, okay, you will not see any effect, or you will see only minor effect, because this AO1, this analog output 1 is providing the voltage to the external world, or you can say it is providing the voltage to this DC voltmeter. But this DC voltmeter is consuming some voltage to turn on its own circuit. Okay, so that is why it is not showing any values on the 7-segment display. If I increase the value to 500, then you will see something. Okay, you will see it is showing something, but you cannot read it properly. You have to increase the value beyond 600. Okay, then it will go dark. Okay, you can see 2.99. Now you can see it clearly. Okay, 2.99. If I increase the value, okay, suppose 700, then you will see the value change, like 3.22 is there. Okay, so if you increase the value up to 900, then you will see much update on this DC voltmeter. Okay, 3.59. If I increase the value up to 1000, then you will see around 4 voltages on the DC voltmeter. And so this analog output card is providing voltage to this DC voltmeter, and according to that voltage, this the value of DC voltmeter is varying. Okay, so this is how you can test your analog output channel of this Modbus IO card, and this is how you can turn on and off your equipments in the field using Modscan software, and you can test your Modbus IO card. Okay, so if I place something here, then on the coil status 5 you will see the value 0. Okay, because right now I have placed something on my sensor, and my sensor is not providing any voltage to this card, so that is why it is showing status as a false. If I remove my screwdriver, then it will show status as a 1, because it is providing 12 voltage to this card. Okay, and if I increase some voltage here, like 500, okay, I'm providing the raw value, but whenever I provide raw value to this AO2, it will convert into voltage. Okay, and that voltage is directly linked with the AI1, so you will see some proportional change in this analog input channel. Okay, so this is how you can test your 2 Modbus IO card. If any analog input is coming from your external world, then you will see those raw values here. If you are providing some analog output voltage to external world, then you will see those values in the 40,001, 40,003, 40,002 or 40,004 holding register of this IO card. Okay, and if you are operating something, or if you are reading some status from your field devices, then you can see those status, and you can operate those things from the coil status from 01 to 08. 01 to 04 is associated with the digital output, and 05 to 08 is linked with the digital input. Okay, and here 40,002 to 40,005 is linked with the analog input channels, and here 40,001 to 40,004 is linked with the analog output channel. So I hope this thing is clear to you. And this 2 Modbus IO card is brought to you by the Augmatic Technologies Private Limited. They are the manufacturer of this card. Okay, so if you want to buy this card, then you can directly visit their website. You can call on their salesperson number, and you can directly place your order. Okay, so I hope this thing is clear, that how to troubleshoot this card. Okay, so if you have some question or concern related to this card, related to any troubleshooting, related to any testing, then you can ping me on WhatsApp, Telegram, Instagram, anywhere, and I'll try to resolve your doubt as soon as possible. Okay, so we will meet you in the next video. Till then, take care, goodbye, and thank you.